Okay. So, Stacy, find a minute.
Which chapters?
So, physics 108. So, any questions to solve?
Can we see like a specific question? You want to see it?
Sure.
Number 3.
Number 3? 4? Okay, I'm going way down now for the other one. Okay. So,
Which one is this on?
this is fall 2019, test 1.
Yeah.
Okay, so this is a projectile question,
Which chapter is it?
which is chapter 3. Okay. A bullet is fired horizontally from a cliff that is 19.6 meters tall. If the initial speed equals 400 meters per second, how far from the base does the bullet land? Thank you.
Thanks.
Okay, so because not everyone's necessarily on the same page, the first question, I will walk you guys through my suggestions and how to go about solving, and then later in the review, I'm going to ask you guys to tell me what to do. But I can't expect you guys to know what I assume you to know without stating it. So the first thing I recommend doing for a problem is just writing down everything you know. So you read the problem and you find everything you know. So bullet is fired horizontal. You have 19.6 meters tall with an initial velocity of 400 meters per second. So those are the things we know. But if I was to draw this problem, here's our bullet. Comes off. What starts happening to the bullet? After it pushes it down, does it go straight down? No. There's a cone. X marks the spot. So we fall down like that. So how many dimensions are we moving in? 2. So in projectile problems, so 2D kinematics, it's important to break up what you know into 2 dimensions. X and Y, horizontal and vertical. And the things we can know in a projectile problem are the initial velocity, v naught, the final velocity, v, the acceleration, a, the distance. I know Dr. Walzer usually uses x, but to not confuse you with the direction x, I'm going to use d. And the time. So now, here's the tricky part that can make or break the problem. We need to correctly identify what direction everything is in. So, 19.6 meters, that's the distance. Where would I put it? Wow. Okay. Okay. What else do we have?
Initial
which direction? Yes. We are 5 horizontally, so our initial velocity is in the x direction. You have a bullet, comes off a cliff. This is the initial velocity. Okay. Anything else we know? Gravity. Yes. So these are the 2 things the problem tells you directly. Dr. Rosa is going to expect you to know things like that. And the things that you are not told directly, I'm going to put in green. So when you are practicing at home, you will remember these are things he expects you to know. So you said gravity. What is the acceleration due to gravity? Not correct. We can just use 10. X or Y? Y. Things fall straight down. Gravity's always in Y. Okay? What does that mean the acceleration in x is? No. So, it is 0. Because if I let this guy fall, what's the initial velocity in x right now? 0. Does it move in the x direction at all after I drop it?
No.
So the final x velocity was still change in velocity in x, 0. Okay. If the acceleration is 0 in x, what does that mean final velocity is? 400. Okay. Just one more thing.
The initial velocity of y is 0
Why?
because it is not moving.
Yes. The initial velocity in y is 0. You're coming off a cliff. You're not moving in y. You have to start somewhere. You start at 0. Then you fall. Okay. And those things in green are things you're not going to be told in projectile problems, especially cliff problems. They'll expect you to know. Okay. What are we being asked to find?
How far?
Yes, we're looking for the distance in x. Okay. So, that's what we're looking for. So, you guys are all given an equation sheet. Do you all have your copy? So now, you guys will dramatically whip it out and take a look. Dr. Rosa tells you what chapter to look for. Can anyone come up with a suggestion of what equation to use? Nick?
Do we need to find time first?
We do need to find time. Good. So, our 3 equations, well, he went by some differently from me. If we want to find the distance, we go with x. We need to know how long we're traveling. Because if we don't have a time, that means we can just keep moving, keep moving, keep moving, keep moving. So we need to find time. So, first step. Find time. How can we find time? We use an equation.
We use the equation v equals v initial plus at.
Okay? So if we were to use that equation, what would I plug in?
We need to switch up the variables.
Okay.
So get t amount.
Get T1?
Yeah.
Okay. then what will happen?
That will give you the time of the y.
Time
Or
of y.
what time has.
Okay? So if I was doing this in the x direction, v final is
0. It's 400.
it's 400. The initial is
400.
400 minus 400 is,
0.
okay, the time is 0. Can we use this equation in y? Do we know the final y velocity? No. So we try again. And this is what taking the test is going to be like. You're going to be using try or error. Because no physics problem has the same methods of solving. Okay? Now the equation suggestion. Looking for time.
X equals 1.5 v naught plus v.
Yes. I'm going to use D so you don't get confused with direction X. Okay? So which direction will we be using in this equation? X or Y? Y. So use Y. So if we use this equation, we plug in our distance, 19.6. V naught, 0 meters per second, that's time, plus 1/2, 10 meters per second squared, time squared. What happens to the first part? 0. If you ever see me write an arrow like that, that just means it goes to 0. So you guys are not allowed calculators. So the next step would be to round this. 20 meters equals 1/2 times 10 meters per second squared times squared. So now we just solve. 1/2 times 10 is 20 meters equals 5 meters per second squared times time squared. Next step. We are left with 4 second squared equals time squared to get time. Okay. So there's something special about time. It's the same in both directions. Okay. Now, can we solve for the distance in x? Yes. Now, what equation do we use?
X equals 1/2 v initial plus v final.
Yes. Times time?
Yeah.
Okay. We use that equation. Distance in x equals 1/2 times v naught 400 plus v 400 time. What's 1/2 times 400 plus 400? Yep. And the time we got was, what do we get for distance? Question. How's everyone feel on that question?
Sorry.
Alright. Any questions on this problem? Okay. Any other specific problems? Okay?
If no one else wants
Okay.
to put on.
What is it?
It's about would the weight of Mars, a 100-pound person on Earth, given that they give you the gravity on Earth and then on Mars, or the radius of Mars.
Okay. That is more complicated. Okay. Can I see the...
Yeah.
Thank you.
Remember to put that on the exam and then,
Okay.
yeah, and no one knew it.
Okay. So, this is a problem from chapter 4.
So you have to find like your weight on Mars.
Okay. What would the weight on Mars of a 100-pound person on Earth be? Weight on Mars of a 100-pound person. He gives you some constants. G equal to 6.67 times 10 to the negative 11 million meter squared per kilogram squared. And moles 6.4 times 10 to the 12 kilograms. All moles 3.4 times 10 to the 6 meals. Okay. Thank you.
Thanks.
Okay. So, in this problem, what do we know? So, the one number we're told in the question specifically is what?
100 pounds.
So what is that number? What is it representing?
Weight.
Weight. And which planet?
Earth.
Yes. Okay. And then we have these constants, which I'm not going to spend time rewriting, if everyone's okay. Okay? What are we trying to find?
What would that person have on Mars?
We're looking for the weight on Mars. Hey, what is weight? Once we do the problem and say, don't tell me. Wait, don't tell me, so please show. Okay. So how does, yep. Yes. So your weight is your mass times the acceleration due to gravity, which you call the g. I'm always going to say what I'm referring to with gravity, because you have the acceleration due to gravity, you have the force of gravity, and you have the universal gravitational constant. And it helps you guys understand what is going on. So weight is the mass times the acceleration due to gravity. So if we're on Earth, we know the weight. This will be equal to the person's mass times T. Is pounds a metric unit or an English unit? Metric unit. Pounds is it. Pounds is an English unit. newtons, the metric unit, is the unit for force. This G will have to be in feet per second squared. But we don't actually need that to solve this one. Okay. I'm going to write down that G out of is equal to 10 meters per second squared. Okay? Mass. Does the mass change when you go to Mars? Do you get bigger or smaller when you go to Mars? No. The mass is a constant. So I'm just going to call this M. Okay? So now, since mass is a constant, we need to find how G on Mars compares to Earth. Okay? How can we solve for the acceleration due to gravity of the planet? Okay. I don't have all of the equations. I don't know what equations he has on the sheet. I know there's one of them is force of gravity equals big G times mass 1, mass 2 over radius squared. Does that look familiar?
Yeah.
Okay. Force of gravity can also be m times g. So if I just want a g by itself, I can divide by mass. Okay, Fg over m equals g. Okay. Well, I can do that over there. I can get rid of one of these masses and leave us with little g equals big G times the mass of the planet over radius squared. Is this equation on your equation sheet?
No.
No. Are you guys allowed to write on your equation sheets? You either will want to have this equation on the sheet, or you will want to measure this guy.
I think the second one is sort of kind
The thing,
Yeah.
the black card,
Yeah.
is we have to
Okay.
have that.
You if you divide by one of the masses, that leaves you with G. Okay. So, okay. So, we're looking for G on Mars. Should have just stuck with wet for the wet planets, but what is the universal gravitational constant?
6,
Yep. Okay, what's the mass of Mars?
6.4 times 10
Okay. And what is the radius of Mars?
6.4 times 10 to the 6.
Radius square that. And now you'll probably look at this and feel sick. That's a lot of numbers. That's a lot of superscripts. I don't have a calculator. What should I do? Yep. Okay, so those of you who've had me at the Bicycle Center know my first step. Those of you who haven't, and then I don't know what Dr. Rosa, what methods he teaches you. I know the topics because I meet with him once a week. And 3 twice a week I have him for class. But I digress. So G moles. So the first thing you should do is move the tens to 1/2 of the equation and keep the numbers in another half. Because a lot of the times for Dr. Rose's problems, he's looking for the power, not the number. So this leaves us with 6.67 times 10 to the negative 11 Newton meter square kilogram cancels over times 6.4 times, yeah. I brought my rule, I kept the 10 mil. Okay. Times 3.4 mil squared. Then you rewrite the tens. 10 to the negative 11 times 10 to the 3rd over 10 to the 6 squared. Okay. What does 10 to the 6 squared become? 10 to the 12. 10 to the 6 times 10 to the 6. Like I do with the fraction when I have an exponent at the bottom. Subtract it. So that becomes 10 to the negative 11 times 10 to the 3rd times 10 to the minus 12. That would be the same as subtracting the 12. What does this power become? 10. You have minus 23 times 23. You get 0 or 1. So minus 11 minus 12 is 10 to the minus 23. They cancel each other out. You get 10 to the 0. 10 to the 0 is 1. You guys all know anything to the 0th power is 1? Okay. Well, that's nice. We can forget about that for now. It's just 1. Now you guys have the last question. Okay. So now we have 6.67 times 6.4. What number can we round these guys to? So we can say 1 is 7 times 6. All over 3.4 squared, which has to be close to, it's going to be bigger than 9 because of the 0.4, so I'm going to make that a 10 to make it friendlier. Okay, so you get 7 times 6. What's that equal to? 42. Over 10, meter squared, and cancels. We're left with a Newton per kilogram. 10 is still, 10 to the 0 times 1 is still here, that's just 1. So we get 42 divided by 10. Meters per second squared. Okay. G on moles is 4.2 meters per second squared. Okay? So, if our M times G on O is around 100,